So today we're going to start with solving problems involving rational functions. Okay. So in a rational function, just a quick reminder. Uh-oh. Our functions, okay, where you basically have a polynomial in the numerator and denominator. Our quotients of two polynomial functions. Okay, so for example, if you have some function f of x, it's going to equal some polynomial over another polynomial. Okay. Some generalized polynomial, we'll call it lead coefficient a sub n, x to the n power. And then the degree just drops all the way until you hit some x coefficient and your constant coefficient all over another polynomial. We'll call it b sub m. And it goes all the way till you get to your b coefficient and your constant coefficient. Okay. That's kind of just the general definition of a rational function. All right, so for example, okay, let's say if we had at 10 a.m., let's say there are 115 performers. And 1,200 spectators at a music festival. Okay. Now, after 10 a.m., clean that up some. Five performers leave every 20 minutes. Okay. And 50 spectators leave every 20 minutes. Okay, so what is the ratio of performers to spectators at noon? Okay, so the first thing you want to do is you want to create an equation for the number of spectators after 10 a.m. and the number of performers after 10 a.m. Okay, so we know that after 10 a.m., 5 performers leave every 20 minutes. Okay, so for our performers, we'll call that P of X. Okay, so if you started with 115 and one leaves every, 5 performers leave every 20 minutes. So that would be after the first 20 minutes, you'll have 5 leave. The second 20 minutes, you have another 5. The third 20 minutes, you have another 5. So as X increases, let's say X would be the number of 20-minute intervals. Okay. So about the spectators, we'll create one. Uh-oh. We'll call that Q of X. Okay. So we know we started off with 1200. Oh, actually, this should be spectators arrive. Sorry about that. Every 20 minutes. Okay, so if 50 spectators arrive every 20 minutes, that means after 20 minutes, 50 arrive. After another 20 minutes, another 50 arrive. So every 20 minutes, you get another 50 spectators. Okay. Now we know from 10 a.m. to noon, you have 3 20-minute intervals every hour. So that means between those, in that 2-hour span, you have 6 20-minute intervals. We'll bring that up some. So between 10 a.m. and 12 noon, there are 6 20-minute intervals. Okay. Now for your ratio of performers to spectators, we'll make that some f of x equals performers to spectators. Okay, so that's your ratio of performers to spectators, which we already know for our performers is 115 minus 5x over 1200 plus 50x. Okay, so that's our ratio after 10 a.m. So we want to find out after 6 20-minute intervals, what's the ratio then? So we let x equal 6, and that gives us 115 minus 5 times 6 over 1200 plus 50 times 6. Right. So that gives you 85 over 1,500. And if we divide both of those by 5, we end up with 17 to 300 ratio. Okay, so you have 17 performers per 300 spectators. All right, so any questions on that one? All right, I'll leave that up for a few seconds. All right. Okay, so let's say, for example, at 11 a.m., let's say there are 400 members and 150 non-members. In a museum. Okay. Now, after 11 a.m., ten members leave every 5 minutes. And 5 non-members arrive every 5 minutes. Okay, so what is the ratio of members to non-members at 1 p.m.? Okay. So this one, we want to do the same thing. We want to find out the ratio of members to non-members after 11 a.m. So we create an equation for members after 11 and an equation for non-members after 11. Okay, so we know that our members, we'll call that our P of X. Okay, so we know at 11 o'clock there were 400. Okay, and 10 members leave every 5 minutes. Okay, so after 5 minutes, 10 would leave. After 5 more minutes, 10 would leave. After 5 more minutes, 10 would leave. So we'll let X equal the number of 5-minute intervals. Okay, and we do the same thing for non-members. Okay, you know, at 11 o'clock, there were 150. Okay, but we know every 5 minutes, 5 more arrived. So that's going to be after 5 minutes, 5 arrive. After 5 more minutes, 5 more arrive, and it keeps on going. Okay, so we have our P and Q, our numerator and denominator. Okay, so we know that there are 12 5-minute intervals in an hour. So that means between 11 and 1, you have 2 hours. That means you have 24 5-minute intervals. So there are 24 5-minute intervals. Between 11 a.m. and 1 p.m. Clean that up a little. All right, so that's the number we're actually going to plug into our ratio. Okay, so remember your members to non-members ratio. Bring that up some. Equals your members equation, 400 minus 10x, over your non-members equation, is 150 plus 5x. Okay. So we already figured out we have 24 5-minute intervals. So we let x equals 24. Okay, so that's going to equal 400 minus 10 times 24. We'll bring that up some. Over 150 plus 5 times 24. Okay, so that ends up being 160 over 270. And if we divide both of those by 10, we end up with 16 over 27. Okay, so at 1 o'clock, you have 16 members for every 27 non-members. All right, any questions on that one? Okay. Yep. Make you do that up for you. That looks like everyone's done. All right, so let's say, for example, do one more example of this one. Say if you have a chess player, won 3 out of 4 games. Or you can just say 75% for matches. During a tournament. During a tournament. Okay, so her goal is to win 90% of her matches. So her goal is to win 90% of the tournament matches. Okay. So how many more consecutive victories would she have to have in order for that to come true? So how many more consecutive tournament games would she need to win to meet her goal? Okay, so we already know she's starting off at 3/4 or 75% of her matches. That's how many she won. Okay, so let's say if she won one more. Then that means she'd be 4 out of 5. Or 3 plus 1 over 4 plus 1. Let's say if she won 2 more. And instead of 3 out of 4, she'd be 5 out of 6. Or you can say 3 plus 2 over 4 plus 2. Okay. So you kind of see the pattern there. So we know, let's say f of x would equal 3 plus x over 4 plus x would represent her winning x number of additional games. Okay, so this represents the winning percentage if she wins X number of games. Or you can say additional games. Okay. Now we want to know exactly when that will become 90%. Okay. So that means we want to know. So we want that percentage to be 90%. Okay. And we know 90% is just 0.90 or 0.9. Okay. So all we have to do is replace that f of x with 0.9. So you want to know when 3 plus x over 4 plus x equals that 90% goal. Okay. So then from there you just solve for x. Okay. So if we multiply both sides by 4 plus x, we end up with 3 plus x equals 0.9 times 4 plus x. So bring that up a little bit. Okay, so we can go ahead and distribute our 0.9. Okay, so 3 plus x equals 0.9 times 4 is 3.6 plus 0.9x. So clean that up a little. So if we subtract 3 from both sides, that cancels out. We end up with x equals 3.6 minus 3 is just 0.6 plus 0.9x. Now if we subtract 0.9x from both sides, that cancels out. 1 minus 0.9 is 0.1. Oh, bring that up a little more. Okay, so we have 0.1x equals 0.6. Divide both sides by 0.1. You have x equals 6. Okay, so she'd have to win 6 more games to reach 90%. All right, so the first thing you want to do is you want to create, depending on what ratio you're looking for, you want to create an equation for both your numerator and your denominator. And then after that, you got to figure out your x values. All right, any questions on that one? All right. Looks like everyone's done. Okay, so we're going to do a quick review on x and y intercepts, and we're going to go a little bit further. So finding the intercepts of a rational function. Okay, so we know that to find the x-intercept, we make y equals 0. Or in most cases, your f of x would equal 0. And for our y-intercept, we just make our x value equal 0. All right, so for example, let's say what is the y-intercept for f of x equals x minus 3 times x minus 7 over x minus 8. So we know y-intercept, just make all the x's equal 0. Okay, so that means our f of 0 is equal to 0 minus 3 times 0 minus 7 all over 0 minus 8. Okay, so you have negative 3 times negative 7 all over negative 8. Negative and negative is positive, so you end up with positive 21 over negative 8. You can just bring the negative out front if you want to. Okay, so that's just the y value of your y-intercept. Your actual y-intercept is when x equals 0, y equals negative 21 over 8. Okay, so that's your actual y-intercept.